Okay, so I'm gonna get started. If I get some viewers, they'll be fun. But right now, I'm just gonna get started. So I was gonna say, I think I have a plan for today, which is that I want to test the bot that I'm working on positions from puzzles, or I shouldn't even say that. I want to try this position that I saw in a puzzle the other day that I got wrong. Um, this is a position, a puzzle where you kind of have to sacrifice. Wait, I actually don't remember what the move is anymore. I remember the move is this, but I don't know why. So let's see. So you check the king, and I guess what? I don't remember how this works anymore. Somehow this is the move, right? It looks like a sacrifice, and then I think, how do you win this? Oh, here. Yeah, so it's mate in two. So it's mate in two, but it requires sacrificing a rook, which is something that my a bot that only considers material will never find, right? So no bot that just wants to count material is going to say I'm going to give it my rook. Um, First off, if it's only just counting material, it won't even see this move as a gain. It's a zero gain because it didn't gain any material. But if it looks ahead one move, it'll say, oh, well, then I just lost a rook, so why would I want to do that? But it has to be able to look ahead two moves to be able to see that you can checkmate the king. So anyway, so I plugged in this position into the code, and here we go. This is working. Okay. So I plugged into this the code. I did that down here. So I created a main function for this custom engine script, and so I create a board with this position. That's the fen for that position. Then I open up. I create one of my engines. I don't know if this is the right stuff to pass in. I just passed in some stuff to make it not crash. I guess Lichess bot API, or the bridge that the Lichess developer created, requires some stuff to go in here that I'm not sure exactly what it's supposed to take in. What is this? It's supposed to take in, let me just check it. So it takes in, the thing is, it takes in these args, and I don't know what that is. Let me see if we can trace it back. So these are these arguments. This is for minimal engine, so maybe engine wrapper would tell me what the args are. Looks like it's past, yeah, it's going into the engine wrapper. Then commands, options, standard errors. So commands aren't used. Are they used here? I don't actually know what they're used for. Well, there's a bunch of features in the Lichess bot API that I'm not using right now. I'm just doing something that's searching for the best move. There's nothing else going on. So we'll learn about those later, probably. But let's see. So what else do I want to show you that I did? I only did a little bit of this previously. Sorry, I did stuff in between sessions because I was bored and it didn't seem like it was worth recording. So I'm running a search on this and I'm just printing the move. So this is not like it's not like the best code for, this is not a proper unit test or anything. It's just, I just know that when it prints the move, I know which one's the good move and which one's the bad move. And so I can run this, but actually before I run it, I'll also show one more thing. I also wanted to measure, last time I ran this search bot, this minimax score function, and it was really slow. And so again, today's goal is going to be to optimize that. And the first step I wanted to do to optimize that was to check how many times we're sort of evaluating the same positions. And so to do that, I created a cache, which is also going to lead to a way to mitigate any problems we might have with repeat positions. So I created a cache object. It's a dictionary, which is a hash table for, it's Python's version of a hash table. And I just check, is the board position that we're considering in that hash table, and if it is, so what I'm doing. So if it's in there, I increment a counter by 1, and if it's not, I set the counter to 0. So what this will do is the first time it sees a position, it will set the counter to 0, and then each time it sees a position another time, it'll increment it by 1. So what you'll end up with is a count. If we count, add up all these numbers, we'll get a count of how many times we saw a position for at least the second time. So it's a little bit, there's some off by 1 stuff that could happen here, but I think I got that right. In contrast, that this max depth reasoning is definitely wrong. I want to fix that in a minute. But what else? Okay, so we can run this and we'll see a couple of things that print out by it. So it takes a few seconds, and this is I guess one thing I had some notes on this. So I think I checked on Wikipedia, and the approximate branching factor for chess is 35, and so that gives us back of the envelope estimate that if we go to depth 2, we should require looking at about 1,000 positions. If we go to depth 3, we should need to look at 43,000. If we go to depth 4, we should need 1.5 million, and if we go to depth 5, it's 52 million, and then depth 8, which is kind of like a standard, like good depth, is 2 trillion. so that's a big number. So here we saw duplicates. There were 14,000 duplicate positions, and this is depth 3. I think I have it coded as depth 2, but that's not accurate. It's because I'm having this function go to depth 2, but it's actually called by a function that does 1 depth, or one ply. Right, the search function itself looks over all the possible moves available to it. So technically, really what I should do is pass in current depth is 1. I think, is that a good way to do it? I don't know. This feels a little hacky. There's some, I'll have to do some more care with this max depth reasoning. But for now, just so we are aware, when I set it to max depth 2, it's basically doing three moves deep. And that would mean that it should be about 43,000 moves to consider, and and 14 of those are duplicates. So we can trim those off, and that should give us a pretty good savings. But anyway, so we found the right move. Let's look at the D4 H4. That's this move. That's what we want. And as a comparison, if we here, how do I go back? If I compare, if I set the max depth to 1, so it's not looking ahead. It's looking ahead only 1 move. This is where it should not want to. This is where it would see that the rook would be lost. So if I run it again, see that there were no duplicate positions, and then it wants to make some random move, h7, h8. Let's look at what that is. h7, h8. Wait, whose turn is it? Oh, sorry, the 7 is here. It's moving its king randomly. Like, why is it doing that? Is it really just a random move, or is there any benefit to this? Well, it doesn't matter. Whatever it is wrong, because this is a mate in 2 position, and we just gave that up. Actually, I wonder what Stockfish says. Is it still mate in 2? No. Yeah, we just lost. We just lost the game. Yeah, so it made a losing move because it wasn't able to look ahead to 3 moves ahead. And then we can also check depth 0. So that's just looking at material, raw material in the next position. And just as out of curiosity, G1, G3. That's a pawn move, right? G1, no. What, G1, G3? Oh, no, it's this. Oh, so it's like, okay, free pawn, right? This is the problem we saw in that bot a few sessions ago, where it looks like it got a free pawn, but it didn't realize that in chess, the other player gets to move next. And so there's lots of ways that you can take back. This one way. I guess, I don't know if that's the best way. It's probably not. I just moved away from the center. Probably here would be better. Or maybe even taking with the rook. Not that it matters, because if someone makes this kind of move in a mate in 2 position, I don't know. Okay, so the bot's working, and there's an opportunity to prune. So with low depth, there weren't any duplicates, but with depth 2, there was a duplicate. So, or the tens of thousands or 14,000 duplicates. So let's go to depth 2 again, and let's do, okay, so now what I'm doing with this cache, I'm storing it in a hash table where I'm indexing by the FEN code, which is, it's nice that Chess has already well established a hashable code that, captures a position. So let's see. So rather than keeping this as a counter, what we really want is to just remember the minimax score, right? The score output by this function here. So I think we can probably, oh, here's how we would do it. So if it's in the cache, then we just set the score. Let's do it this way. Let's do if it's not in the cache, just so that that's I don't know. I think stylistically I want that to be the default. So by default, we assume it's a new position. So we see this new position, we compute the minimax score, and we happen to do that with this recursion and whatever. So, but then we set this minimax score to whatever we saw. Wait, hold on, something's not right here. Well, so here's what I want to do, and let me tell you about why I don't think it's right. So first, we set the cache value to the score, and then here we will also set the here is where we already have cached this value, so we might as well just look it up. So in fact, we don't want to do this. We just want to set. Whoops. We want to do score equals that, right? So now what we're doing is, when we see a position that we've already seen before, rather than calling the recursive, running another recursive call, we just look up in the table what the score was. And what I'm not doing is we'll have to sort of eyeball whether this is getting us a gain, because there's overhead involved with this stuff. But we know that, I was running it anyway. So it took a few seconds before. Hopefully it will take half those many seconds or something like that when we run it again. But okay, here's where I'm a little confused about whether this is the correct thing to do. We might encounter a position at different depths. So if we encounter a position at a higher depth, I guess here's what I'm saying. Like let's say we get to a position 3 moves after looking ahead 3 moves, and then as we look down another path of possible moves, we did discover it after one move, right? So this can happen if there's like a piece moves back and forth. Which score should we use? So the score that we computed at 3 moves is going to be more heuristic, right? We will not, from that position, we will not have looked ahead further as far as we would have had we started it from the first position. So, I mean, it's not the end of the world. I just worry that we might come back to the current position. No, that doesn't make any sense. No, this could be a problem. I think I need to hash it by not just the position, but the depth. Does that make sense? Yeah, so my problem here is that if we run it like this, we will have we might have a lower quality estimate for the score of a position and store that in the cache. And then later on, if we see that position, had we run the full search, we would have gotten a higher quality estimate. And then I guess I can try to avoid that by saying that we will only do this if the depth. Okay, here's one possible hack. We can store the depth that we cached at each time, or the depth that we were at when we cached each score. So I can say cur depth here. So we're storing a tuple that's going to be the current depth, and and this is the first time we store it. And then in here, when we want to look it up, we only take it if we are reaching it at a, let's see, at a later depth. Yeah, if we're at a later depth. Because if we reach the position, if we reach the same position at an earlier depth, we have an opportunity to search further. And we want to use we want to use the deeper search. So okay, let's try this. This is this might reduce the amount of savings we get, but it won't make us do some bad estimates of the position values. Okay, I'm gonna say, so we'll get the old score and old depth. All right, so we grab the old score and the old depth, and then we just say if old depth, which way did I say I want it to be? If it's greater than cur depth. Okay, if it's greater, which way do we want to do it? So the old depth was deeper. The deeper it is, the worse of an estimate it is, because you would have less opportunity to search further down in the game tree. So old depth and current depth. So this is deeper. It's less. So then we want to recalculate it. So we actually want to call the full computation and store. Actually want to do this. So there's some repeated code here. I probably should refactor this, right? This is identical code. But for now, let's just do this. I think that works. Let's see if it finds the right move, and let's see if it finds it reasonably fast. I guess there's no good way to test. You know what? Here, I'm going to do something a little hacky. So old version. So the old version doesn't do any caching at all. It's just going to, here's what we're going to check. We're going to compare against this. And just quickly hacking, because this is going to be, I'm going to comment this out, and what I'll do is I'll run this version with the cache. First I'll debug it. I'm sure it's going to crash, but once it runs, I will then compare against this one. So this is the old version. So let's run it, depth 2, and probably should do a time. I don't know if I can do time it here. No, I don't want to do that. I'll just do, let me give system.time, or the time, the Python time, so I can count stuff. All right, so I'm going to do start. Is it time.time or time.now? Well, I'll find out. Okay, let me see. Is this what I want? Return the current time. Yeah, that's just fine. Okay. Actually, this should be up here. Oops. All right, so I'm going to run this. Well, let's just get the baseline first, just because I don't want to deal with I don't want to deal with this when this goes wrong yet. All right, so if I run this, this should work like it did before. Hopefully gives us, yeah, D4H4. It ran in 3.8 seconds. And then now let's try the caching version. Okay, it crashed. All right, so score, best score. This is wrong. So I want score, and we just ignore the depth. We don't care about the depth there. Seems longer than 3 seconds. So I'm doing something wrong, or there's a huge overhead here, or something. Or yeah, it looks like something's wrong. Okay. This line will no longer run. Let's just delete it. But so it seems like it still took longer than 3 seconds. or 3.8 seconds. So I could just be incurring a huge overhead to do this. We can think about how to make it faster, or maybe we can just like move on from here. Yeah, it's like 9 seconds, same move. We can actually count. There's no good way to count it. Well, maybe I'll do just as a hack. Let me just do a. I don't know if Python will let me do this. I'll just set cache counter. Oh, can I do? No. You know what? I think what I want to do is. Well, let's walk through this. Let's see if this is doing what I want. So if it's a new position, this is the new position situation. It calculates the score, it caches it, and that's good. If it's an old position, right? So it's one that's been seen before. We get the old score and get the old depth. That should be really fast. And if the old depth is greater than the current depth, meaning that we saw the position deeper in the tree. I'm sort of worried that this is just happening every single time, but yeah. So if you saw that deeper in the game tree, then yeah, then we still do the recursive call, and then we cache it, and only if we saw it. Well, I guess this might help, but probably not. Only if we saw it. Wait, no, sorry. No, I want that. If we saw it at a shallower or equal depth, then we use the cached value. I guess this is where I want to count, right? So like this is where we get any savings. So how much savings do we get? I'll use a global variable. I know it won't let me do it. Okay, I had to do like the global flag or something. It's probably not a good practice. How else could I do this? I feel like I want to use the debugger and count. I think there's a way to do this. Can I count the number of times we enter this position? Or let me just debug and see if we ever enter it. Okay, so we are there right now. I wonder, okay, so as a sanity, I mean, one thing we can check, one curiosity is how big is the cache right now? So cache. 1040. So we checked 1040 positions, and we had a cache hit once. Let's check it again. 1074. Well, now we're getting more of them. Yeah, they're happening pretty frequently now. There should be some savings, but it's yeah, it's really slow. Okay. I was hoping this would actually give us some speed up, but maybe we just move on to pruning. The question is, do we keep this caching? I think we have to. I mean, I think we have to go to deeper depth. You know what? I'm going to try it at depth 3. And let's just do this while we talk about pruning. So I'm going to run the old version. We're going to run the same experiment with depth 3, see if we get any savings. Depth 3 takes a long time. Oops. But it's also quite, oh shoot, what did I do? Okay, run. So this is running using just sort of, the full search without any caching. And while we do that, so the strategy for pruning, there's a famous algorithm called alpha beta pruning, and the way that works is that with each call, with each recursive call, you keep track of an upper and lower bound of what you think the value could be for every node. Right, so every node in the tree has an upper and lower bound, and you can calculate that. You can reason about that because you can, once you see, for example, one possible path down the tree, Actually, it's not even a full path. It's not a possible path. I mean, so for example, one upper and lower bound is that if you've calculated the full subtree of that move, you know exactly the upper and lower bound, right? You know the exact value. So the upper and lower bound are equal, and they are the actual minimax score. But then what that tells you is the parent of that node is then bounded by that one child that it's seen. So in other words, think of it this way: like if you're in a position where it's a mate in one, and you try a move, and you discover that it's checkmate, then you already know the value of the position you're in, right? The value of the position you're in is, whatever the mate value is. What did I set that to? Was it like 99? 900. Okay, yeah, it's already 900,000, right? It's like you already know the value of the position. But as a result, you don't need to search for the other moves. Like there's no point of looking at the other moves because you already know the value. So alpha beta pruning follows a similar principle. It gets a little complicated with an upper and lower bound. So what I want to do is I just want to try to encode the principle that whenever we run a search for, whenever we call minimax score, the question we want to answer is not what is the minimax score of this position, but is this minimax score, is it possible for this position to be better than one of the other options I have? And so what I'll do is I'm going to pass down, well, I have an idea of how to do this. I'm not sure if it's actually correct. And the weird part is that, so I've taught AI a few times now in my career, and every single time I do it, what I'm about to write captures the intuition of alpha beta pruning, but then again, I'm not going to use an upper and lower bound. I'm just going to use like the best sibling I've seen so far. That's the principle. Is that whenever you're searching through all possible moves from one position, you will keep track of what the best possible next position is that you've seen, and if the position, if a candidate position cannot be better than that one, then you just stop searching. You just stop searching that tree. So we'll try that out. But anyway, so this is with depth, what did I say? Depth 3, which is actually depth 4. And it took, 2 minutes. So now let's see if we get any gain when it's a bigger tree. Does the caching make a difference? I don't know. This might take forever, but let's just run it. Yeah, it's possible that there's just too much overhead in what I wrote, or there's a bug in what I wrote. So let's just try the pruning let's try to start setting up pruning. So we have this cache thing. I want to now pass in something I'm going to call a cutoff. And I guess I'll put that at the beginning because I want it to be required. Well, I don't want it to be required. Let me set it to be, I can set a default. So it doesn't have to be required. So the default would be something really small, because the way I wrote this, I'm always looking at a positive score, which I'm also sort of messing with standard minimax. Normally the minimax code is written like with a min player and a max player, and the way that I wrote it is that it's always the max player, but then you kind of like reverse it. Here I'm passing, I return the negative score. So I'm doing some stuff that might mess up the logic and could introduce bugs, but I'm trying to make the code simpler so I don't write the same code for a min player and a max player. Like if you look at pseudocode for minimax and for alpha beta, pretty much it's all repeated code. Everything repeats twice, once for the min player, one for the max player, and then when it's the min player, everything is negative. It seems like it's I just have a hope that you can write it without doing that. I might be wrong, and that will mean when I have to start all over again, but we'll see. All right, so I'm going to set this cutoff to something tiny, and I've been using these placeholders. We've got to do better than that. Let me do another digit because I want it to be worse than checkmate. Okay. So my thinking is that the contract will be that this minimax call is going to look at all the moves and it's going to keep track of the best so far, and which it has right here. This best score. Oh, you know what? I have float inf. Let's do that. I'll keep using that. Oops, not negative negative. That would be positive. Okay, negative float inf. Wait, will this work? Because this is running code. It doesn't feel safe. I'm gonna try this. I'll fix it later. At some point, I'll just make a placeholder for all these negative 9. Yeah, this could just be. Let me just make one a constant here. Oops. Infinity equals float inf. I think math.inf also does this, but then I have to import math. Oh, or I could just do this. Is that a clean way to do it? Python style doesn't like this. Unused. Oh, it's just because it's unused. I will use it. So this checkmate, do I want to make this infinity? I think I don't want to do comparisons with infinite values. So this I want to, yeah, so this took longer. So this caching stuff doesn't work at all yet. This is messy. I'm going to take it away and just to simplify, you keep it as a simple form. I gotta, this has to be helpful, right? Like this is called a transposition table in standard minimax or game programming parlance, and I know it's useful, so I must just be coding it wrong. All right, so we're doing a cutoff. I'm going to set this to be infinity. Now I'm using it. Okay, and okay, so my thinking is that I'm going to keep track of this best score, which we do anyway, and what we'll say is I want to pass the cutoff. Oh, I can't do that. I have to just write it. I have to write best score. Now I have to think about the sign here because I keep flipping the sign. I kind of think it has to be minus this. Okay, so here's what I'm thinking. I want to say that as soon as I discover a move that's better than the cutoff, I wanted to stop the search. So that's my reasoning, is that as soon as the cutoff is basically saying if the opponent has an opportunity to make a move better, if the opponent has an opportunity to make the score better for the opponent than my best position so far, there's no point of continuing to search this position. So score, the signs are a little tricky. So the way I did it is I'm doing minus. Okay, so I'm passing in the negative score. I'm sorry, I'm returning the minus score because this is for the opponent. So if the best score, the cutoff that was passed in is minus infinity, I think I want this to be infinity. I think, and now if score is better than cutoff, whoops, off, then I'm just going to return best score. I think that should, oh, nope, that won't work. Okay, so now my question is, what am I supposed to be passing for this? Should I pass in minus best score or best score? Probably minus best score. And best score is minus infinity. So let me think about this. So let's just run through the initial case. So first, best score is minus infinity, right? That's just the placeholder, right? So everything should be better than that. So in the first move, it recursively calls to find the minimax score of the position, of the new position after making the move. It gives that child, recursive call a positive infinity cutoff. And so now when that child is run, it's going to compare against positive infinity, and it will never be bigger than positive infinity, so it won't cut off, which is what I want. At the beginning, I don't want it to do any cutoff. Later on, once it's found a best score, suppose it finds a checkmate. So it found a checkmate on its first move, and now it's looking at a second move. And the second move is it passes in, the minus checkmate. Okay, so this would be like minus 9,000 or 900,000, and then the child, when it compares against its cutoff, any move that is not checkmate would cause it to stop searching. I don't know. This sort of feels like it might work. Now, I guess I'll just try max depth 2 again and see if it crashes. I'm sure it'll crash because I'm sure there's some reasoning I did wrong. Okay, 2.62. That's smaller, right? Wasn't it? I don't remember what it was. So if I turn off, wasn't it 1.8? Let me try it again. Well, let me turn off this cutting off stuff and see if I just get rid of this so it doesn't do it. It was 3.6. Oh, okay, so there was a speed up. 3.6 pretty consistently, and then if I allow cutting off, I don't know if I might have added overhead, and then so there's a speed up only after the overhead. I vaguely remember it being faster, but this might be okay. So again, you're not going to get much pruning at low depth, so I'm going to try this. This took 2 minutes before, so now I'm doing increased depth. Let's see if it works. The other thing I can do is actually count the number of positions that we're seeing. It's a little tricky to do that in a functional way. So I have to return the count somehow, or use global variable, which I didn't know how to do before. It's pretty slow. Well, yeah, it's faster. I mean, it took 2 minutes before. Now it takes 50 seconds. Of course, it didn't find a better move because this is a mate in 2, so you really only needed depth 2. So this might be working. It might be working. Let me hide this improve score. I'm not using it. I could use it. I could improve the heuristic, but right now I'm just using material count as the heuristic. I wonder, let me think. So, like, this roughly accomplishes what I wanted to do today, in the sense that it sort of works, but it's like still really slow. So I wonder, I was hoping that like the combination of these two things would help, but this thing didn't even help at all. So maybe it's worth debugging this, because I wonder how many duplicate positions we're seeing now. Or I could do the thing I didn't want to do, which is I could try this, but not care about this depth stuff. So I could just use the cache every time. So what this is going to do is it's just, oh, I don't even want this. Yeah, anytime we've seen it already, we just use the previous value. I don't know if that's going to get the right moves. It's definitely not the right thing to do. But if it gets us fast move, we'll see. Let's see. So I'm going to run it with 2. So we're comparing against, like, I don't remember, was it 2 seconds or something? Okay, it crashed because int current depth max. Okay, why is this complaining? So what? So current depth plus 1. Somehow current depth became a dictionary. Oh, because of this. So I called it wrong. So I had to call it with the cutoff again. I didn't here. This cutoff should be here. Okay, cutoff like that. Yeah, I think the way that I'm testing this is not ideal because I'm just like trying to remember how long it took. I should really be counting the number of positions and then the number of times we use the cache. The number of times we prune. That seemed, wait, no, that was really slow, right? This should have been 2 seconds or something. So if I turn this stuff back off, oh shoot, I'm doing both. But yeah, anyway, so let me think about. Let's try to be more precise here. We want to actually count these things. So. Let me just quickly look up how to do global variables. I know it's not the right thing to do, but why didn't this work before? This seems like the same thing I just tried. All right, let me just try it again. It seems like you just define it. You don't need to do this stuff. So this is you use the global keyword if you're creating a global variable from within a function. But yeah, we weren't even doing that, so I don't know why it didn't work. Let's see. So I'm going to set some diagnostic variables. Let's say and so we will look at cache hits would be here. Oh, actually, you know what? This is so slow, right? So like, this is 6. Let's just count them. See, yeah, why is this complaining? So unresolved reference. It's right there. Why can't I do this? Like in general, I think what's happening is Python's telling me not to do this bad coding habit, but I just want to do the quick and dirty thing. But the right thing to do would be to somehow. Oh no, because there's so much recursion. I don't want to pass in a cache hits count that then it's incremented. And, I mean, I have to pass it by reference. I don't. That sounds really nasty. Well, I'm doing it with a cache anyway, so that's one way to do it. Let's do. Oh no, we don't have to return it. It's such a mess. Okay, am I doing something wrong with this cache? like I'm passing it down, right? If I pass it down, it's not getting a reset each time. That would be bad. Well, all right, so what I'm finding is that this is slow. So let me think about this. Is there something wrong with this? So it could be some overhead from just like dictionary hashing, but how could that create much overhead? That's like a really simple arithmetic. I mean, the fen is a string. It's like somewhat long. Maybe there's a way to directly encode this in some binary form, but I really don't think that's going to be really slow. So it generates a fen. It generates. It checks it. You know, it checks whether it's in the cache. And then we run this. This should be the same as the old version, the non-caching version. And then we just store it. We store it inside the cache. So what's wrong with that? And then if it is in the cache, then we just compute the score here, and then we don't bother computing it here. And then we return. Yeah, then we just run the same checks as normal, and then we return when we're done. Well, I don't know why this is complaining. Let me just do a little more. This maybe something on Stack Overflow would help. So I'm looking for. How do I even search for this? So unresolved reference. This is not Python. It's not. I should, yeah. Okay. Well, maybe it was. Oh, I didn't recognize this as Python because they were using capitals, not following standard Python style. Okay. So they're using global here. Should I use global? I mean, I can just try that. I mean, the question, does that overwrite this thing? I don't know. Okay. Did I spell it wrong? Cache hits. Cache hits. Okay. Global cache hits. Pruned. Does it let me do 2 in a line? Okay, that's running. Other than I actually don't do anything with cache hits, but let's see. So let's print out this stuff. Print. I mean, do I need to do global here as well? I don't know. Let's see. Probably not. This is not inside a function, right? This is an if statement inside the main script of Python. All right, so I'll run again. It should take 5 seconds. In the meantime, okay, so 0 prunes. What? Oh, right. I'm not counting them. Okay. Yeah, so 7,000 cache hits. I guess the question then, the other question is how many positions do we evaluate? So let's do that. Positions 0, and why don't we just do positions, and right here we should just right away increment. Okay. Oh no, what am I doing? I just want to type position. I want to print out the positions count. Right, comma there. Okay, and pruned. I'm not counting the prunes, so let's go to where does that? When does that happen? That happens here. Okay. So this will help us diagnose what's happening. So we pruned 581 times. That doesn't actually tell us how much we saved, because each time we prune a subtree. So we actually don't know how. We can kind of estimate how many positions we would have saved, right? Because you could actually prune, just like 10 times and save a huge amount, like everything in the entire tree. Anyway, so there were 18,000 times that we called minimax. We pruned 581 times. I mean, this doesn't really tell us the whole story of what we saved. It really seems like the cache should save us something, because like each time we're caching, we're essentially pruning. Five seconds for depth 2. That's not very fast. I guess something must be messed up here. Let's just go. Let's check this. So let's do without cache hits, or without the caching. So it was like 5 seconds. So this time we saw this many positions. So that gives us an idea of how much the caching saved, but it ended up being faster. Same number of prunes, which is, or does that make sense? That suggests that every single time we cached something, every single time we used the cached value, we didn't actually save a pruning opportunity. Interesting. Positions. Okay. Now I guess let's see what happens. Let's just compare against if we don't do any pruning. So now let's turn that off. See what we get. Yeah, so it's not a huge savings at depth 2. At depth 3, we saw a big savings, but it took like 50 seconds, which is just too slow for a chess computer. So we definitely want to do the pruning. Now the question is, there's other aspects here that I can further optimize, which I won't be able to get to today. You know what? Let's just play against the depth 2 computer. It's actually depth 3, right? It's depth. I call it depth 2, but it's actually depth 3. Let's set it up to play, and I guess we'll do it. I mean, the way we're doing it is this is not working, so this is. Let me just write a note here. Caching is probably working, but overhead makes it slower. And pruning seems to be working. All right, there's a possibility that like my simplified pruning strategy is just missing pruning opportunities that the full alpha beta like upper and lower bound might be able to catch. I doubt that, actually. I think that's just not. I doubt that would make a big difference. I think the bigger thing that's happening here is that a smart engine would be clever about which positions to try first, and that changes how much you prune, right? How much you. Oh, someone's. Oh, sorry. I'm sorry. I missed all these chat messages. I have to declare cache hits as global. Yeah, I finally did that. Cache hits at 0 depth. Check something. Oh, I see. Yeah. So you call it global inside the function. Yeah, I didn't know that. I feel like I've written scripts. You know what? I think it's probably because I'm thinking. No, I've definitely done this before in like Jupyter notebooks where I declare a global variable and just directly use the variable without having to declare global inside the function. I wonder if it's a difference in Jupyter notebooks than in the Python script. But anyway, thanks for the tips. So this is counting. Right. Okay. So where am I? So right. What I was saying is that if we were smart about which positions to try, we can find pruning opportunities first, earlier. And the way you do that is you basically look for like the most promising positions first. Once you found the most promising positions first, because then you have a more aggressive cutoff. And the way you do the way you get the most promising positions first is that you don't do this depth first search the way that I have it recursively programmed. You do an iterative deepening search, so that you get a really cheap estimate of the value of each position, and then you can use that estimate to order the moves. So that's something we could try next time. But let me spend a few minutes playing a game against this bot. So it will take like a few seconds per move, which is fine. And we can then get some more qualitative analysis of what's going on, or rather qualitative analysis of how good this thing is at depth 3. So Lichess bot, I think I'm going to run this script. I also did some configuration. I think last time one of our viewers tried to play a game and that caused an interference with mine. My bot wouldn't play a game because it turned out it was configured to play only one game at a time. Now other people can play it, but it will just kill my laptop, which I'm running all this on. All right, let's play a game against the Bert bot. How do I get to Bert bot? Search. Oops, there we go. Yes, BirdBot is online. We can play against it. Let's just start a game. Okay, yeah, so one thing we saw last time that we'll continue seeing is that it has no clue what to do in the opening, because looking ahead 3 moves, considering that guessing that I will play optimally, like the opponent, guessing that the opponent and the computer will both play optimally, basically every move in the opening is like equally good. So computers have no clue what to do. With this algorithm has no clue what to do. All right, so I guess I'm tempted to push this away, but it doesn't really matter, right? So like, it's not really threatening anything. So I'll just take the center, and then now I'm threatening it with my queen. Make sure you can see what I'm looking at. All right, so it's defending. It defended. That's good. That's promising. It's definitely an unorthodox opening. So I still don't want to overreact to this knight in my territory, because I would guess that it's not really an issue because I can just kick it away at any time. But at some point it might become an issue. So I'm just going to continue developing. Yeah, that move makes no sense. Let's try to think about why did it do that? Is it again a situation where every move is equally good in this situation, or is it just a straight up bug? I think last time I thought it was doing something dumb, and it turned out it was actually smart. Because you think in tactical positions, a look ahead of 3 is better than I can do, right? Like as an amateur player, three move look ahead is pretty high level in puzzle rush, right? Or when you're given a chess puzzle, while a computer can do it kind of perfectly, or at least this computer can do it perfectly when it comes to material count, right? If you can figure out how you can win material by looking ahead 3 moves while also considering all the possible moves your opponent can make, then you can do really well in a lot of puzzles, which amateur players like me are not fully capable of doing. But this doesn't look like a good move. This rook lift, this early rook lift. So I suspect that's just random nonsense. I think what happened, I tried playing a game against this bot a couple days ago, and what was happening was I saw it make silly moves, and then so I started making really aggressive moves trying to catch it, and then I lost, right? Because once it got to a tactical position, there was no way I could compete with it. But anyway, so my instinct here is just to develop. I don't see any threats. Yeah, so it's confused. So let's just continue developing. Do I castle here? I don't really want to castle with that knight in my position, or right next to my king. I can castle later. Yeah, so it's totally confused. So I'm just developing the standard, ideal squares for everything. And given that the opponent made no actual moves, I'm now 3 tempos up, I think. maybe given the situation, I actually want to castle queenside. So I'll defend the pawn, and then let me guess, rook. Yeah, something. Okay, so this could be a bug, and if it's a bug, we will address it. Again, it's also possible that really is three move look ahead at this stage, when there's no development on the bot side. There's just no moves that are better than other moves. Okay, let's start attacking. So what's a good way to attack here? Probably kick the knight out first, I suppose. I don't know. This is such a weird position. Okay, so it's knowing to it's doing the right thing of avoiding a piece getting captured. All right, so now I'm thinking. Oh, and it's also defending this square, which is pretty good. It's pretty good that it's doing that. Well, I'll just take this. No, I don't want to trade. Okay, let's try to open up the game, and then not only will that see, like, that's how you win this position against a human, but I feel like if I open up the game, I'm gonna start losing, because then, oh wow, okay, how could I lose this game? This is gonna be so embarrassing when I lose this game. I'm just gonna try to pawn storm down the middle. Okay, this makes no sense. So this could just be bugs. I might have pruned away something that I shouldn't have pruned away. Or is this really... Let's threaten the queen and threaten this fork. If the bot's really looking... Oh yeah, so okay, that's pretty good, right? So I mean, it's not amazing, right? It's probably not. I'm sure that move is not good objectively, but it at least defends the square, which is what I was threatening. And I don't think if you weren't looking ahead, I mean, think about what has to be looked ahead there. Like, first off, the bot would lose a pawn, which is not a big deal, but then they would lose a rook. So that does require some look ahead that I think the bot had to really consider. So now what? Now. What's a good move here? I could further attack that by pushing this pawn, but it's a pawn sacrifice. I don't know if I want to do that. Maybe I'll... Actually don't know what to do. This is such a strange position. Well, I know, I'll just open... Well, that doesn't work either. I kind of... Okay. I'm paralyzed with so many options that are all strange looking. I wonder if I'm... Oh, you know what? I can look at the console. Is it taking longer? Oh, it's not printing anything. Yeah, it's because of the concurrency that this code here does it. It hides the console output. Otherwise, I'd be seeing stuff like how many positions are being pruned. Oh wait, what just happened? Okay, so this looks good for me. I think I want to take... Okay, that looks like... I think that was the right move because, well, maybe not, but trading is better than losing the rook, I suppose. So far what we're seeing is some bad moves, but not ones that I can obviously punish, like with my skill level. I mean, this qualitatively from like basic chess principles, this position looks really bad for white. We know that development is good. There is no development happening. The early queen moves, but that doesn't matter unless I can punish it, which I can maybe. So if I threaten it, does that buy me anything? Not really. I mean, it's like I'll just keep pushing the queen around, but I'm not like gaining anything. Like it's not like my bishop is better placed here than. Well, at least now it's lined up with the king, but then it'll get kicked away any second. So I kind of want to do this pawn sacrifice. No, but then the bot can just push here. So this, I don't know, like there's a couple possibilities, right? A lot of times when you build these AI things, you start to hallucinate whether they're like really smart, or if they're just doing random stuff, and you can't really tell a difference. Like this stuff this position looks really bad for white, but at the same time, I don't know how to punish it, and so maybe it's actually not that bad. You know what we can do? No, I don't want to cheat. Other people can look at it, or maybe after the game we can do something. Let me play fast. I'll play fast. I'll probably lose once I start playing fast. Then we can do an analysis and compare against what Stockfish says about this. I mean, this must be bad for white. But here, I'll threaten the queen. Oh shoot! I just lost my knight. Oh man, I can't take back. Okay, fine. I can recover. Oh no. Yeah, this seems good. Okay, now it's threatening check. I'm gonna lose. This is now this is completely losing. I'm almost certain that my king is super in a ton of danger. I'm about to go to the left side of the board for me, which is wide open. Okay. Yeah, and now it's getting its other pieces in. I think this looks okay. Okay, what? That was weird. I wonder why I thought that was a good move. Well, let me go back. What am I missing? It has 3 move look ahead. Am I about to get checkmate or something? Like what am I missing? That looked like a mistake. So we had to consider that. Like that could have been something I pruned incorrectly. I don't see how a 3 move look ahead would have missed losing the free piece like that. Oh wait, where are all my pawns? Maybe I'm not really winning. I kind of want to just trade off the queens. Oh no, because I'm down. What am I down? I'm down. Right, I lost that knight earlier, but now Bertbot lost a bishop, so I'm doing pretty well. I really don't know what to do. I'll just keep pushing its queen around. I don't know. Okay. Okay. The king lift. See, there's almost a discovered tactic here, but can I somehow defend this square and then still do that? Probably not. Yeah, I'm stumped. It's still sort of there as long as if I can just get the queen out of there. Okay, I'm going to threaten this pawn, see if that helps. Okay. Maybe trades are good for me. I don't know. I want to finish this game, but the more I rush, I just hung that piece completely straight up before when I was trying to rush. I have no choice, right? I have to move here. Can I counterattack? Not really. Oh wait. Oh no. So I saw this checkmate, but it's not a checkmate. It would be hanging if I moved here. It looked like a checkmate for a second, but it's not. It's defended. Okay. Yeah, I have no choice. I have to move here. Okay, it's threatening my knight. Oh, interesting. This is a good. That was a good move. Again, it could be randomness, but look. So, can I get out of this? Right. So this knight is defending the bishop. Knight's defending the bishop. Knight's now under attack. So I can defend the knight. I guess that's how I get out of it, as I defend the knight. Doesn't feel super safe anymore. I mean, the pieces are all coordinated, but I feel like it feels kind of brittle. This is so frustrating. Okay, I'm threatening to push this pawn. No, I'm not, because I need the knight is tied here protecting this bishop, so I gotta get this bishop out of here. This looks okay. Looks okay. So does this work now if I push? I'm not counting correctly, but this is where a bot will definitely out count me, because a tired human. Yeah, did I just give up a pawn for no reason? I did, didn't I? No. Right? Wait, what? Did I miss something? Is this hanging? This bishop is hanging. No, it's not. No. Why did it allow me to do that? That's weird. Okay. So we can figure out if that was. I mean, there's a free pawn here. Oh no, sorry. I just keep missing things like this. No, that is definitely a defended pawn. So what do we do now? Gotta get the rook out of there. I could just defend it. That feels dangerous. I'm sort of tempted just to set up another discovery. Yeah, let's trade. Okay. That's weird that the bot took that trade. Why would it do that? Probably that there's no, I mean, the other thing I know about engines in general is that once they're in a really losing position, they just make random moves because nothing is good, right? Every move is bad. So kind of like, anyway, well, this is an end game, although this is also where the engine's going to shine, because it's just, it can look ahead. Well, that's not true, because I limited its depth. What would happen is, if this were like a better programmed engine, once there's fewer pieces on the board, there's fewer moves, the branching factor shrinks down, then you should be able to look deeper. But my engine doesn't look deeper. But if it could look deeper, then it would be like an unbeatable end game bot. Right? My bot here is probably beatable because it can only look ahead 3 moves. But 3 moves is still a lot for a human, right? In some situations, You know, the way we do it as humans is we kind of like, we have these heuristics to like prune things away quickly. What is happening here? I'm just gonna eat some pawns. That's not threatening anything, is it? Well, now it is. What have I done? Oh, why did I do that? I did it all wrong. We come back. I had a discovery attack against the rook. Stop. Okay, this might take a long time. All right, there's no way the bot can get in now, so I'm just gonna, yeah, okay, now it's just confused. Okay, no stalemates. Probably, wait, what is that threatening? Nothing really, right? I don't want to allow that. Did I just lose? No, I didn't lose. Okay, so I don't have anything better than promoting this pawn. Okay, let's see how it does. I mean, okay, it doesn't do amazing. What's the fastest way to do this? Here, yeah, right there. Okay, let's look at the analysis. This is interesting. So now, again, we're comparing against Stockfish running in my browser, which is a million times faster, a million times better program than what I've done. But let's see. I think there was an interesting situation I was wondering about. Well, actually, yeah, this is so interesting, right? So here, it's basically even. I guess I'm up like slightly. Here I'm winning, but is there any obvious like line that like makes me winning? I mean, let's see, what's my best move here? Like I'm winning by a lot here, and it wants me to move here. I mean, these are so hard to calculate. Like it's just like a, what is my advantage? Am I up a piece here? I think I'm up a piece. So 2 bishops. No. What? It's just based on development. Okay, so starting from the beginning. Right, so there's this nonsense where eventually, right, like there's a position where no pieces have been traded and BirdBot like undeveloped all of its pieces, right? So this is like a you know, like an odds match situation, and you know the engine, you know, Stockfish at depth 21. Oh man, how do they get it down to all the way to depth 20, like 20 something, so fast? But right, it's saying that I'm up like a queen when no pieces have been moved. It's just a development lead. I mean, it's a huge development lead. I'm fully developed, and all they've done is push flank pawn. So the question is, I mean, this is something we can work on, right? Like, how does a computer know that this is better? I mean, it's looking ahead 20 moves. Does that suggest that in 20 moves I could like trap its queen? I mean, it seems unlikely. So again, here, still materially, right, it's even. Stockfish wants me to sacrifice my knight? For what? And then wait, what is going on? And then the pawn? Oh, that leads to winning the queen. Okay, so the whole sequence of that was Stockfish saw this that my bot did not see, and my human version of myself did not see, which is here. Okay. Oh, sorry. Ah, shoot! I lost that line. Okay, so the line was sack the knight, sack the bishop, sack the pawn, or not the or discovered attack, discovered check on the pawn, and then you win the queen. Is that really unavoidable? So it's claiming that this is unavoidable. Can I turn on other lines? Okay. Well, anyway, yeah, this makes sense, right? This is okay. What about that? This is such a weird position. Well, okay. So what do I learn here? That's one thing. The other thing I want to see is that the time that the bird bot gave up its rook, not its bishop for no reason, right here. So first, it seemed like there was no reason to do this. Does Stockfish think that this was actually a good move? I don't think so, right? So right, I mean, okay, it's jumping around. That's also interesting. Like, you know, a sign that it's a complicated position is when Stockfish like sort of like changes its mind. But like this, that must be bad, and it's done calculating to the max depth that the browser version allows. And it just lost material, right? I wonder why BirdBot did that. Maybe we can diagnose that later on. So next time, one thing we could do is look at this position and see why did it want to take. So I can get the fen for this. I can save it somewhere. Fen's here. Copy, and I'll just plug it into our custom engine. Okay. Oh shoot! What just happened? What? Why is it? That's so annoying. It like put all these new lines into it. Did I copy it wrong? Well, it put new lines into it. I'll deal with this later. This is just a minor thing. All right, I gotta get going. Hope this was interesting for everyone, and I'll post this on YouTube as usual. And so you can, you know, I'm sure, I don't know how many people were watching live. I know we had one participant in chat, but yeah, for sure, I'm getting the main audience is people watching it archives on YouTube. So yeah, check it out. Next time we'll figure out how to make this even faster, and so that we can go deeper, and or actually try to diagnose some of this stuff. I'm not sure if there's actually been a problem. And eventually I want to leave the bot up and just have it run. But for now it's still just running on my laptop when I choose to turn it on. Okay, so yeah, I hope that was enjoyable for you, and have a great week.